Hey guys, so we talked about yesterday about how to add and subtract rational expressions, and now we're just going to do some harder ones. So for number one, you still need to factor all terms in the denominator. So for this one, the bottom of the first one can be GCF'd. It has a GCF of 6, and that leaves me with x minus 2. And the reason we do that is because now they have something in common. They have the x minus 2 in common. So I'm going to set up my common denominator. So I'm going to include that x minus 2 that they have in common already. And then you bring down any oddballs. So this 6 right here is an oddball. That also comes down. Alright, so since the first fraction already has that LCD, I am just going to recopy the top 3x. But that second fraction needs the 6. So I multiply by 6. That's going to make the top of the second one 12x. So then yesterday I told you that if there's a minus in between it that you needed to add the negative. So I'm going to add and make that a negative. Then step 4 is to add or subtract numerators. So I can add these two. They are like terms, 3x and negative 12x. And that gives me negative 9x. And it's all over my common denominator of 6 parentheses x minus 2. So then I will need to factor and cancel, and I can't factor the top, but I can cancel or reduce the 9 and the 6. So I can use my calculator by putting that in and hit math, enter, and that would become a 3 up top, and the bottom would become a 2. And that's my final answer. Number 2, so I'm going to factor the bottom of the first one first off to the side. I'm going to do slide and divide. So put 4 up top, 5 down bottom. What multiplies to 4 and adds to 5 is 4 and 1. You can use your calculator. So that's x plus 4 and x plus 1. I can't factor the second denominator. So now I compare what they have in common. They have an x plus 1 in common. So that's going to be part of my LCD, is the x plus 1. And then that x plus 4 is just an oddball, so it also has to come down. So the first numerator can stay as it is because it has both the x plus 4 and the x plus 1. So I'm going to recopy 6x. The second one, though, it does not have the x plus 4, so I'm going to multiply by the x plus 4 on top and bottom. I'm going to distribute that to 2x plus 8. Notice I have not canceled anything yet, and that's going to be your biggest temptation, is you're going to want to cancel things out before you're actually able to. So I'm going to combine like terms. 6x and 2x is 8x. And then I have that 8 that doesn't have any friends, so I just bring that down. I put it all over my common denominator. Last step, I factor and cancel. So I can factor the top and 8 out. I'm left with x plus 1 over x plus 1, x plus 4. And I can now cancel at the very end. So my final answer, I'm going to write it up here, is 8 up top and x plus 4 down bottom. All right, the next one, I can factor the bottom of that first one using difference of squares. It's a minus b, a plus b. I can factor the second one with GCF, 4, and I'm left with x plus 3. So what they have in common already is they both have an x plus 3. So I'm going to bring that down into my LCD. And then the other two things I'm going to bring down as oddballs. So I'm going to bring down that x minus 3. And I'm going to bring down that GCF of 4. So I use colors because we now need each denominator to have a green, a yellow, and a purple. So the first denominator, what it needs is a green. So I'm going to multiply the top and bottom by 4. And I have to distribute that 4, so I get 4x plus 8. The next one has a green and a yellow. It needs a purple. So I'm going to multiply by the x minus 3. And I'm again going to distribute the 7. 7x minus 21. Now I can add like terms. I'm not canceling anything yet. I'm going to add those two first, and then I can combine 4x and negative 7x, and that gives me negative 3x. And I can combine the 8 and the positive 21, and that is 29. It's all over my LCD, and I cannot factor the top, no GCF, so that's my final answer. All right, the next one. When it is like this, when you have two different binomials, the easiest way to do that is to bring both of them down as part of your common denominator. So I'm going to bring down x plus 3, and I'm going to bring down x plus 2. So that means I need to multiply by the first one, by the purple, by the x plus 2, and I need to distribute that 5. So it's 5x plus 10. And I need to multiply the second one by x plus 3, the yellow. Distribute, so 2x plus 6. I'm going to add the negative now. And I'm going to combine like terms. So I can combine the 5x and the negative 2x and give me 3x. And I can combine the 10 and now negative 6 and get 4. And this is all over, again, my common denominator. The top doesn't have a GCF, so I can't. All right, so for the next one, what we need to do is we have to get a common denominator by factoring the bottom of the second one, just like we did in the previous ones. 2 up top, 3 down bottom. 2 and 1, multiply to 2 and add to 3. So we do that because now we see they have something in common. They have in common is an x plus 2. So I'm going to have x plus 2 in my common denominator, and then I'm also going to have an x plus 1 because the other one has it. So the first fraction has the x plus 2, but it needs the x plus 1. I need to distribute the 2. The second one doesn't have anything that needs to be changed, so it can stay as a 2. I'm going to add the negative. I can now combine like terms. The 2 and the negative 2 cancel, and I am just left with 2x up top, all over my common denominator. I can't factor or cancel, so that's my final answer. All right, the next one. I can factor the bottoms of both of these. So that factors negative 4 and negative 3, and that would be negative 4 and 1. And this one, I get negative 2 and negative 1. That's negative 2 and 1. So I do that because now, hopefully you see they have something in common. What they have in common is they both have an x plus 1. So that comes down. Okay, and then there are two oddballs this time. This one has an x minus 4, so that has to come down. And the other one has an x minus 2, so that also needs to come down. All right, so the first fraction has a purple and a yellow. It needs a green. It needs an x minus 2. I have to distribute the 5, so I get 5x minus 10. The second one has a green and a yellow. What it needs is a purple, so it needs an x minus 4. Distribute it. 3x minus 12. I need to now add the negative because it's a subtraction sign in between, so add negative, make that a plus. And I'll combine like terms now. So 5x can combine with negative 3x and give me 2x. And negative 10 can combine with positive 12 and get 2. And this is all over my common denominator of those 3 parentheses. I can factor the top of that 2x plus 2, a 2 out. And when I do that, now something will cancel, which is great. The x plus 1's cancel. I'm left with 2 up top and x minus 4, x minus 2. Notice we didn't cancel until the very end. All right, last one. So these have two different binomials. There's nothing I can multiply them by to get the same thing. So I'm just going to bring both of them down. So x plus 1 is going to come down, and x minus 1. That means I need to multiply the first one by the x minus 1, and the second one by x plus 1. Now this is a little bit tricky because whenever we multiply the tops by what they're missing, you need to do the foiling method or the box method. So off to the side, I'm going to make myself a box. I put x minus 1 up top and x minus 4 down the side. So I get x squared minus 1x minus 4x positive 4. So that when I add the diagonal, I'm going to write on the top x squared, that's negative 5x when I add the diagonal, plus 4. All right, off to the side, I'm going to do the same thing with these two. So x minus 2 and the x plus 1 gets me x squared, negative 2x, 1x, and negative 2. So I have x squared. When I add that diagonal there, I get negative 1x minus 2. Now, so I'm going to add the negative, and I'm going to add like terms. So x squared and negative x squared cancel. They're gone. Negative 5x and positive 1x is negative 4x. And positive 4 and positive 2 give me 6. This is all over my common denominator of x plus 1, x minus 1. I can factor GCF out at the top. So the GCF at the top is negative 2. And that leaves me with 2x minus 3. And it's all over x plus 1, x minus 1. I can't cancel anything though, so that is my final answer. And that's one of the hardest problems you'll get.